The equation to obtain the sum of the nth terms of a geometric progression can take two basic forms. The first one is when the common ratio r is less than 1. Then the sum of the nth terms of a geometric progression will be equal to a into 1 minus r raised to power n over 1 minus r. This is because the common ratio is less than 1. Right? You can call this equation 1. But if the common ratio r is greater than 1, the sum would then be equal to a into r raised to power n minus 1 all over r minus 1. And this is the second case we can have. So if you're asked to find the sum of the nth term of a geometric progression, the first thing to do is to check what is the common ratio. Is the common ratio less than 1 or greater than 1? If it is less than 1, then the formula to use is the first one, while if it is greater than 1, the formula to use is the second one. Let us see an application of what we just discussed. The question here is, find the sum of the 9th terms of the sequence. So our aim here is to find the sum of the 9th term. Remember, I said the first thing to do is to check what the common ratio is. And common ratio from our preliminary knowledge is T2 over T1, which is equal to T3 over T2, which is equal to T4 over T3. And we have this to be equal to 20 over 4 is equal to 100 over 20 is equal to 500 over 100. So we will realize that r will be equal to 5, which is equal to 5, which is equal to 5. Okay, so since our common ratio is equal to 5, then we can ask ourselves this question: which formula are we going to use? And remember, I said that we can either use the first one or the second one based on what the value of r is. But in this case, is 5 greater than 1? Of course, 5 is greater than 1. Therefore, the formula I'm going to use is the second one, which is Sn equals a into bracket r raised to power n minus 1 all over r minus 1. If you insert the values of r and a into the equation, Sn equals a into bracket rn minus 1 all over r minus 1. This will give us 4 into 5 raised to power 9 because n is equal to 9. Our question is we should find the sum of the 9th terms. Okay, 5 raised to power 9 minus 1 all over 5 minus 1. This will give us 4 into 5 raised to power 9 minus 1 all over 4. Of course, 4 can cancel out. If 4 cancels out, we are left with S9 is equal to 5 raised to power 9 minus 1. 5 raised to power 9 is equal to 1953125 minus 1. And then the final answer is equal to 1953124. So this is the sum of the 9th terms of the sequence here. This is the application of our knowledge on the sum of the nth terms of a geometric progression. So you can check how vast or how well you've understood this particular concept by solving more problems under this. But if you solve your problems and then you still have issues, you know where to find us at www.awoko.ng, a place where all your academic worries are taken care of.